According to the 2020 National Electrical Code, metal-clad fiber optic cable and medium-voltage MC power cables cannot be installed in the same tray. NEC Section 770.52b2 states that metal-clad optical fiber cables shall not be installed in the same cable tray or raceway with conductors and equipment of power systems unless the cables are listed for such use and installed according to such listing. Medium-voltage MC cables are not listed for installation with metal-clad optical fiber cables. Therefore, according to the NEC, they cannot be installed in the same tray or raceway. The argument that MC cables are considered a raceway and can therefore be used to contain other cables is incorrect. NEC Article 100 defines a raceway as an enclosed channel designed expressly for holding wires, cables, or busbars, with associated fittings, for example, made of metal, fiber, plastic, or non-metallic materials. MC cables are not designed to hold other cables. They are designed to protect the conductors they contain from damage. Therefore, they cannot be considered a raceway under the NEC definition. The correct approach is to install the metal-clad fiber optic cable in a separate tray or raceway from the MC power cables. Considering the installation of metal-clad fiber optic cables and medium-voltage MC power cables, the National Electrical Code provides clear guidelines to ensure safety and prevent potential hazards. The next, specifically Section 770.52b2, directly addresses this scenario. This section explicitly prohibits the installation of metal-clad optical fiber cables in the same cable tray or raceway as power conductors and equipment unless the fiber optic cables are specifically listed for such use and installed according to their listing. This requirement underscores the importance of maintaining separation between communication and power systems to minimize the risk of interference, damage, or even electrical hazards. Medium-voltage MC cables, commonly used for power distribution, are not listed for installation alongside metal-clad optical fiber cables. This absence of listing signifies that these cables have not been evaluated and approved for such combined use, highlighting the potential for incompatibility or adverse interactions. Consequently, adhering to the NEC, these cables cannot be installed together in the same tray or raceway. The rationale behind this restriction lies in the distinct characteristics and functions of these cable types. Fiber optic cables transmit data using light signals, making them sensitive to electromagnetic interference. Power cables, on the other hand, carry electrical current generating electromagnetic fields. Placing these cables in close proximity can lead to interference with the fiber optic signals, degrading data transmission quality, or even causing data loss. Furthermore, the presence of high voltage in power cables poses a risk of electrical hazards, such as insulation breakdown or arcing, which could damage the fiber optic cables or create a fire hazard. The argument suggesting that MC cables can be considered a raceway and used to contain other cables, including fiber optic cables, is a misinterpretation of the NEC definition. Article 100 of the NEC provides a clear and specific definition of a raceway. A raceway is defined as an enclosed channel designed expressly for holding wires, cables, or busbars, with associated fittings. These channels can be made of various materials, including metal, fiber, plastic, or non-metallic materials. However, the key characteristic of a raceway is its intended purpose of providing a dedicated and protected pathway for conductors. MC cables, while providing a degree of protection for the conductors they contain, are not designed or intended to function as raceways for other cables. Their primary purpose is to protect the conductors within from physical damage, moisture, and other environmental factors. They are not designed to accommodate additional cables or provide a separate pathway for them. Therefore, using MC cables as a raceway for fiber optic cables would be a violation of the NEC definition and could compromise the safety and performance of both cable systems. To ensure compliance with the NEC and maintain a safe and reliable installation, it is imperative to install the metal-clad fiber optic cable in a separate tray or raceway from the MC power cables. This separation provides the necessary isolation to prevent interference, minimize electrical hazards, and ensure the integrity of both the communication and power systems. By adhering to these guidelines, electrical professionals can uphold the standards of safety and quality that are essential in electrical installations. To further clarify the requirements and ensure proper installation practices, it is beneficial to explore the specific characteristics of both metal-clad fiber optic cables and medium-voltage MC power cables. Metal-clad fiber optic cables are designed for communication purposes, transmitting data using light signals. They typically consist of one or more optical fibers enclosed in a protective metal sheath. This metal sheath provides mechanical protection and helps to shield the fibers from electromagnetic interference. However, it does not provide the same level of electrical insulation as the insulation found in power cables. Medium voltage MC power cables, on the other hand, are designed for power distribution at voltages ranging from 600 volts to 35,000 volts. They typically consist of one or more insulated conductors enclosed in a metallic sheath. This metallic sheath provides both mechanical protection and a grounding path for fault currents. The insulation used in these cables is designed to withstand high voltages and prevent electrical breakdown. The differences in design and function between these cable types highlight the importance of maintaining separation. Placing them in close proximity can compromise the performance and safety of both systems. The potential for interference with the fiber optic signals and the risk of electrical hazards necessitate a clear separation. In situations where space is limited or it is otherwise difficult to install separate trays or raceways, alternative solutions may be considered. However, any alternative solution must be carefully evaluated to ensure that it meets the requirements of the NEC and does not compromise the safety or performance of either cable system. One possible solution is to use a listed barrier or divider to separate the fiber optic cables from the power cables within the same tray or raceway. This barrier must be made of a non-conductive material and provide adequate physical separation to prevent contact between the cables. The barrier must also be securely installed to prevent it from shifting or falling out of place. Another possible solution is to use a cable type that is specifically listed for combined use with both fiber optic and power cables. These cables are designed to provide adequate insulation and shielding to prevent interference and electrical hazards. However, it is important to verify that the cable is suitable for the specific application and that it is installed according to the manufacturer's instructions. In conclusion, the NEC provides clear guidelines for the installation of metal-clad fiber optic cables and medium-voltage MC power cables. Section 770.52b2 prohibits the installation of these cables in the same tray or raceway unless the fiber optic cables are specifically listed for such use and installed according to their listing. Medium-voltage MC cables are not listed for installation alongside metal-clad optical fiber cables. The argument that MC cables can be considered a raceway for other cables is a misinterpretation of the NEC definition. To ensure compliance with the NEC and maintain a safe and reliable installation, the metal-clad fiber optic cable should be installed in a separate tray or raceway from the MC power cables. If alternative solutions are considered, they must be carefully evaluated to ensure that they meet the requirements of the NEC and do not compromise the safety or performance of either cable system. It's also worth noting that local jurisdictions may have additional requirements or interpretations of the NEC. Therefore, it's always advisable to consult with local electrical inspectors or authorities to ensure compliance with all applicable regulations. Staying informed about the latest updates to the NEC is crucial for electrical professionals. The NEC is revised and updated every 3 years to reflect changes in technology, industry practices, and safety standards. Familiarizing oneself with the latest edition of the NEC and participating in continuing education courses can help electrical professionals stay up to date on the latest requirements and best practices. In addition to the NEC, other standards and guidelines may be relevant to the installation of fiber optic and power cables. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers or the Telecommunications Industry Association. Consulting these standards can provide additional guidance on best practices for cable installation and performance. Proper cable management is also essential for ensuring the long-term reliability and performance of both fiber optic and power cable systems. This includes proper cable routing, support, and termination. Cable should be routed in a way that minimizes stress and strain on the conductors and connectors. Cable should be supported at regular intervals to prevent sagging or drooping. Connectors should be properly terminated to ensure a secure and reliable connection. Regular inspection and maintenance are also important for identifying and addressing any potential problems before they escalate. This includes checking for signs of damage, wear, or corrosion. Connectors should be inspected for loose connections or contamination. Cable should be inspected for proper support and routing. Any identified problems should be promptly addressed to prevent further damage or performance degradation. By following these guidelines and best practices, electrical professionals can ensure the safe, reliable, and long-lasting performance of both fiber optic and power cable systems. Remember, safety is paramount, and adhering to the NEC and other relevant standards is crucial for protecting people and property from electrical hazards.